Hi guys. Welcome to Universe View Odyssey channel. 2023 Nobel Prize in Physics, opening the era of Attoseconds physics. Today, I would like to tell you about the winners of the 2023 Nobel Prize in Physics and their achievements. If I had to give it a title, it would be 2023 Nobel Prize in Physics, opening the era of Attoseconds physics. Q1. Oh, by the way, now is Nobel Prize announcement season. Usually the physics prize is announced first, and it was announced last week. Before listening about the winners and their achievements, I have a question. What is attoseconds? These are the key words of the day. Nano, commonly heard these days, is 10 to the 9th power, pico is 10 to the 12th power, and femto is 10 to the 15th power. And the next one is atto, which means 10 to the 18th power. Attoseconds are a billionth of a second, so, attosecond means an extremely short time scale. Attoseconds physics refers to physics that captures extremely short periods of time. Q2. The physicists who opened the era of attoseconds physics, an era of physics in such a short period of time that is hard to imagine, are the protagonists of this Nobel Prize. Let us first introduce the winner of the 2023 Nobel Prize in Physics. The winners are Pierre Agostini, 82, France, professor at Ohio State University, Ferenc Krausz, 61, Hungarian-born German, professor of quantum physics at Technical University of Munich, Germany, and Anne Louillier, 65, dual citizenship of Sweden and France, from Lund, Sweden. The Nobel Committee said, the laureates have developed a method for generating extremely short pulses of light that can be used to measure the rapid processes by which electrons inside atoms and molecules move or change energy. It provided humanity with a new tool to explore the world of electronics. Q3. You said that today's keyword is attoseconds, but I can't even imagine how short it is. How short a time is it? Can you explain with an example or analogy? If we take the size of a person as a standard, then at the macroscopic level there is the largest universe, and at the microscopic level there is an atom. In terms of time, if our heartbeat time is 1 second, the longest time is 13.8 billion years, 10 to the power of 18 second, which is the age of the universe, and the shortest time is 1 second divided by the age of the universe. This is attoseconds. The scientific community says that attosecond is the shortest timescale that can be directly measured. Q4. 1 second divided by the age of the universe. It's hard to imagine, but I would like to understand it on the shortest timescale. But why such a short time scale? That's because it is the time and speed at which electrons operate within an atom. For example, it takes 150 attoseconds for an electron to orbit the nucleus of a hydrogen atom. So, to capture the movement of electrons well, attosecond-level observation technology is needed. It's the same way that you need to set the shutter speed to fast to take a picture of a fast object. Currently, digital civilization is mostly based on electronic control. If the current nanoseconds physics changes to attoseconds physics, information processing speed will be 1 billion times faster. This means the study of attoseconds has given scientists access to a fundamental process that was previously out of reach. Q5. How do you take pictures of fast-moving objects like electrons? Taking pictures means shooting light to obtain an image. There must be special light, right? In 1987, Anne Louillier discovered that many different overtones of light arose when she transmitted infrared laser light through a noble gas. Each overtone is a light wave with a given number of cycles for each cycle in the laser light. They are caused by the laser light interacting with atoms in the gas. It gives some electrons extra energy that is then emitted as light. Anne Louillier has continued to explore this phenomenon. laying the ground for subsequent breakthroughs. Q6. The shorter the lifespan of a pulse, the faster objects can be photographed. So what is the current record? Pierre Agostini's team developed a pulse lasting 250 attoseconds in 2001, and 2 years later, Professor Laureates' group broke the record with 170 attoseconds, and Krausz developed a pulse lasting 80 attoseconds in 2008, setting a new record. The current Guinness record holder for the shortest pulse of light is 43 attoseconds, belonging to Hans Jacob Werner's team at ETH Zurich in Switzerland. Q7. Lastly, what application areas of Attoseconds physics have been opened by these Nobel Prize winners? It can be said to be all fields related to electronics. First, there is electronic engineering. In fact, almost all digital technology fields currently fall into the category of electronic engineering. It is also used in medical diagnosis, which requires identifying various molecules in the human body. And so-called attochemistry, which controls and manipulates electrons, could lead to more efficient solar cells, or even the use of light energy to produce clean fuels. Closing. Today, we looked at the winners of the 2023 Nobel Prize in Physics and their research achievements. It was a meaningful time for me to first encounter attophysics, which goes far beyond nanophysics and looks into the world of electrons in atoms. Thanks for watching. You can read this story in Injury Time, injurytime.kr.